Yeah. So, hello everybody. I see many of you are younger than me, so you are a dynamic generation, right? No, no, it doesn't work like that. No, sorry. I see a few familiar faces, but a couple words about myself. I love speed of user experience, also called in the industry web performance, although it's a loaded word. But I organize a meetup group about it. This 10 years this year, actually, pretty old group. We have speaker sessions every month, and we also have hands-on sessions as well to help people optimize their websites. Next speaker session is on Tuesday, actually, about scaling the culture of web performance. If anyone is interested, please check it out, NY Web Performance Meetup. And now I actually work at Meetup as well. So I'm joking that I don't only run Web Performance Meetup, but I also do web performance at Meetup. So anyway, that's what I do, and I love this stuff. So why do we generate, right? Like this group is a lot about generation of content, right? The word static generation was mentioned multiple times. Basically, who can relate to not running your own runtime? Who loves that, right? No PHP, no Ruby, no? Java maybe? Anyone ran ASP.NET before? No? Yeah, so welcome. Welcome to the world of none of that, right? Server administration, obviously, tools like serverless, awesome invention as well. But managing that for our static, let's call it content, or content that is not interacting with the user is just awesome. Who loves databases, huh? Anyone? Anyone? 3 people love databases or love that we don't need to care about them anymore? Which one is that, right? So all of those are awesome conveniences for us as creators of the applications, and this is just amazing. I love that, right? But there is one other thing, right? Other than scalability, solutions like serverless allows us great scalability. There is this thing called speed, right? And users don't want slow experiences. And this is what generation helps with, because this is the metric called time to first byte, right? For HTML specifically. It tells you how fast does first HTML arrive for each web page view, right, to the user. And this is like realistic data from some website where this time to first byte is the distribution. It's never one number, right? Speed is never one number. So this is a distribution for different users how fast that happens, right? And you can notice that long tail above 4 seconds, right? Like everybody, that's what that last bar is. It's not like a border or anything. It's actually a data point, right? So it's always a distribution like that. And it's not only high on average in this particular case, right? But it's also very variable, right? So almost 4 seconds, right? Jared showed the statistic with distribution, right? That's basically what this represents, right? The 95th, in this case, percentile is at almost 4 seconds. So what it means is that 5% of your users have experiences slower than 4 seconds, I'm sorry. And this is terrible, right? Because HTML is a bottleneck. Nothing can happen on a page. Nothing can be shown, loaded, interacted with, or anything. And even nothing can even start downloading your JavaScript or anything until that happens. And in traditional systems, that distribution that I showed you is not uncommon, right? How many of you used WordPress before, right? Shared hosting, you know, your WordPress is like, yeah, that graph is actually very optimistic for what WordPress does. You know, comparing to what WordPress is I see. And at our hands-on sessions when we run and analyze websites, We actually ran the meetup, joined with WordPress meetup, and talked about it. You know, it's not uncommon to do, right? While for this particular website, you see that this website ran static resources as well off of Amazon S3, right? Served like all of the JavaScript, CSS files, and that is the distribution for those files, right? 480 milliseconds on average and 629 milliseconds at 95th percentile, right? It's not only faster, but it's significantly less variable, right? So users have a consistently fast experience. And when we talk about generation, that basically moves your HTML from being dynamically generated when a user requests it to being the same as your CSS, your JavaScript, right? Well, you guys are at this meetup. It means you know this awesomeness, right? But this is significant, right? This is great because this first request, again, is a bottleneck. Why does it all matter? For those of you who don't attend my meetup, please take a look for the because almost every meetup I show this slide. These are use cases, business use cases about speed. If you're interested, WPOstats.com, it's like much more on the website, many more examples, where it correlates speed to actual business value. Right? So if you need to talk to your business managers and to your folks, which is always a nightmare, like to explain technical stuff, right? You tell them serverless and they're like, oh, come on, you geeks, right? Here is an example of how to sell it, right? And the numbers are mind-blowing. That's frankly, when I saw these numbers back in 2006, actually, even maybe a little earlier than that, that's why I started the group, right? Because numbers are just crazy. Imagine tripling the revenue of the company by doing something technological, right? How many business people will pass on that, right? Nobody will, right? They would not believe you. That's another story, like how to convince, you know. But hopefully these numbers help, right? Until you can show this benefit on your site, these numbers can help. So it's very important, right? SEO, like they're like just, I mean, read the site. I don't need to explain it to you. By the way, cultural implications we will talk about on Tuesday, right? So I assume, how many of you ran or worked with other websites that are not statically generated, that are big production kind of enterprise systems, right? Oftentimes, well, cache is not used there either, right? But the moment the conversation of speeding things up significantly comes around, cache is edge cache, CDNs, right? Is the first thing that comes to mind for people, right? And today I wanted to talk about start at least with kind of comparison between cache and generation. Why do we generate? Why don't we cache? That in the end, the idea is the same. You don't do real-time processing, right? So this is how cache looks like. Essentially, you have a lot of users in the world. They all access your edge servers provided by some vendor, CDN vendor, which makes requests to so-called origin server, right? And that origin server usually reads data out of a database, hence WordPress or some other applications like that. And all of that happens when user makes a request, right? So when updates happen, they're written into database and the next request from the user goes and grabs it. But CDN can be configured to say, hey, this particular response, please remember it for a particular period of time called time to live, right? And that's those little TTL labels under the nodes show that, right? So next time a user comes to that particular node, they will be given pre-calculated response, right? That being said, there are multiple nodes in the world. Well, multiple as in like hundreds of thousands usually by individual vendors. So it's not like you get only one request for a resource to your server, right? You get quite a few resources, quite a few requests. So comparing that to generation process, we move up origin all the way to some kind of storage. Many of you use Amazon S3, I can imagine, or through services like Netlify, it's abstracted away from you, right? The point is that when the requests coming through this CDN, they go and hit a statically saved file already, right? So it's not only saved on the CDN, it's saved as a resource already. And all the updates and all of the generation, all of the processing to create the output is actually done on the moment of the writing of the content, of changing the content, right? Usually it triggers the rebuild, your process somehow gets the data or maybe keeps the data as part of the Git repository or something like that, and builds the whole thing and redeploys, hopefully only changes to this static storage, right? As you can see, the read of reading during the request is much shorter, right? Like meaning that, first of all, it's also geographically shorter usually, but more importantly, you don't go all the way into your infrastructure. In addition to that, because the generator knows which resources it generated and deployed, it can also use cache invalidation technique, where it tells the CDN to stop caching, to forget the old resource, invalidate it, right? Because of that, the time to live can actually be infinite, right? So if you compare the two techniques, cache renders on the read scenario, basically like non-cached resources, right? It does remember the result, but when it's read, that's when calculation happens. When in generation, it happens on the write. It does use the TTL technique, and the staleness of the resource depends on the length of the TTL, right? Because you don't know when user hit it, right? Like you cached it now, user hit it in 15 minutes, it invalidates later, like in 20 minutes, it means 5 minutes stale, but the user could have hit it right when you deployed it, so it will be 20 minutes stale, right? So average staleness is half of your TTL essentially, right? Among all the users. And that, unfortunately, makes people be very conservative about this caching, right? Because you cannot invalidate, because you don't invalidate, right? That's why you like, oh, let's put it like 10 minutes and we will be safe, right? So 10 minutes staleness is not a huge deal, at least like in publishing world, I heard these conversations a lot, right? So your effectiveness of cache is not very great either. While with generation, it's 100% hit rate, right? Like the moment you deployed, that resource is available until it's overridden, right? And staleness depends on how long you deploy, right? Your data changed, it takes some time to deploy. That's how long your data is invalid, like, or stale, I should say. It's not invalid, it's just old, right? Well, some can argue that it means invalid, but it's old, which is not the same because, well, things take time anyway. You know. Another aspect of the caching system is that it always needs an origin, right? You need to run those servers. There is no way to not run them, right? If your authoring system went down, right, and there is no data, oops, that's a problem, right? I mean, there are obviously solutions for that. So when we say cache only depends on TTL, it's also not completely true, right? Because cache is not caching forever, right? It's not caching universally. We discussed there are many nodes out there in the world, right? So if one cache has it, it doesn't mean another cache has it. Moreover, if you have many users, CDN node has many clients, well, it could have evicted your resource from the cache, right, at that moment in time, right? So it's a shared resource. I'll actually talk about it a little more later. By the way, if anyone has any questions, please feel free to ask them. There is no need to wait.
I have a question that might sit outside this a little bit, but I have a question that might sit outside this a little bit, but do you ever hit issues with browser caching or anything like that in terms of either of these scenarios? In terms of keeping...
It is a little bit outside. It is also cache, but it is a different type of cache. Some of it can be related, but I would like not to talk about it right now. Okay, let's talk offline separately, right? Okay. Okay, so some of you will be like, okay, so why did you invalidate here and didn't invalidate there, right? Like, why are you talking about this inefficiency if you could use invalidation in here as well, right? Well, the difference between generation workflow and this workflow is that in generation workflow, you know exactly what to invalidate, right that moment, right? But in caching workflow, you can invalidate, but all of that logic needs to be stacked on top of your existing system, and you need to put all of that logic, similar to how you know to logic for generation, you need to create that kind of logic to go and do invalidation, right? But it is possible. That's kind of what people do in advanced scenarios, like they put infinite TTL. So if you notice the difference between the two, here the TTL is like conservatively low, and here it's an infinite TTL, and then you invalidate things, right? And when you invalidate things, it goes, grabs the new version, and serves a new version later, right? So let's compare invalidation process with generation. Which one is better, right? I mean, we love generation, right? Like, can we do invalidation instead? Will it be any good if we need to do that for systems that we cannot do static generation for? So first of all, it requires an API call with most of the CDNs. So you need to actually integrate that, right? While with generation, invalidation happens on deployment. That's kind of the point, right? There is a way to configure a CDN to do stale while revalidate, meaning that when you invalidate something, it will not stop serving a resource and go to your origin for request, right? It will serve the old version, similar to generation, right? Until you deploy it, it will serve the old resource. So that's actually on par, right? If you think about it, you will serve old version. Well, granted that that particular cache engine has the old version at that moment, right? So there's still origin needed, but you could do quite progressively with stale while revalidate. So, okay, again, the same kind of level, not again, sorry, API call was kind of disadvantage, but minor disadvantage if you think about it. Then comes a more complicated question. What is that you're invalidating, right? Because nuking the whole cache is kind of not a great solution, because what does CDN do when you do that? It comes back to your origin and kills it, basically. All of the requests start going to your origin when you were not really hoping for that, right? Like you had your smaller server by then, and you're like, okay, now none of your data is valid, like dead, right? How many of you experienced that in your life? Here we go. Yes, that's fun experience for sure, right? But I mean, you could do a little smarter, and sometimes people break up the whole cache into like sections and like CP codes if you're a KMI user and stuff like that, you know. But there are more advanced techniques like surrogate keys. Fastly, for example, supports it. It kind of came out of Varnish world, where you can tag each response with whatever keyword, right? And this way configure things to only invalidate a subset. I mean, you can obviously invalidate just one URL if that's a thing, right? But you would not. I mean, you would not go and invalidate 1,000 invalidation requests, right? You will just tag them and invalidate them all together, right? So it's kind of similar to incremental building in static generation, right? If you only updated these resources, well, actually, incremental deployment. If you only updated these resources, go and invalidate only those resources, right? Kind of similar. Again, kind of on par, right? So if you look at it, these techniques are more or less the same with minor differences, except for the kind of the price that you pay for edge cases and things like that. So first of all, we discussed shared CDN nodes. Node in Moscow, so they're called POPs. Points of presence, by the way. You know, points of presence in Moscow might not have a resource that you're trying to fetch, right? And when POP in New York cached it, Moscow node doesn't know about it, right? Akamai, I think, has 100,000, or at least they declare 100,000 POPs, right? So all of your users are not accessing the same cache at all, right? But also, you have long tail content, right? Things that are rarely accessed, right? Among your million pages, homepage is accessed quite a lot, but like some rarely accessed resource, it's unlikely to survive in the caches for a long time, right? Because those caches are usually least LRU caches. Least recently used, that's right. I'm blinking out, sorry. So it means that it will evict, all of those nodes will evict your rarely used resource, and your hit rate will be very low, right? It will always go to origin to generate, right? It's not, as we discussed, there are a lot of things that you can do to minimize that, but still you will have that impact, right? You still need origin. You need some of your users, though, remember we talked about 5% in the end, right? Like distribution will still be flat, right? While with generation, well, whatever you generated will be there, right? You have a long tail, well, you pay for the storage, and once you pay for the storage, however billion files you have, there will be billion resources to serve, right? And there is another obvious cost. It takes time to generate, right? You take CPU to generate. So the narrower you are in what you regenerate, the better, but it's a hard problem to solve, right? And probably you all know it because you use static generators and they freaking regenerate the whole thing. Some of you use Hugo, though, I hear, right? And that's much better, right? Yeah. I'm not a huge user of serverless, so and I don't have sides. I don't take sides in this fight, right? But that's a kind of a problem, right? Especially if you have a lot of data. And that's kind of what I want to talk about in the second part of the talk, kind of talking about different versions of static generators and generation workflows, I should say. Starting with the most common one, the static generation out of Git, where all of your data is versioned in Git, events are handled by Git, webhooks, whatever that process is, right? Even if you use this external CMS will publish content into Git, right? And that is kind of a centralized data store, right? Pretty good. Doesn't solve for content contributed by users necessarily, unless you have that service also doing the same thing. Kind of breaks on like billion terabytes of data. I'm kidding, this is a big number anyway. But on high amounts of data, on high amounts of updates, right? Might not work for your huge enterprise, let's say e-commerce website, right? With a lot of sales and things like that. But it's robust, it's kind of has everything controlled in one place, and we love it for that reason, right? It's amazing for smaller projects, does magic, right? There are also static generators that do API calls to external systems. If you ever used Contentful, I think it was their first thing. I don't know if they publish to Git these days, but they definitely like specialize on content as API, right? Or any other external resources or whatever, right? And during your build, you can go and like you have your code running in your repo, but it goes and fetches list of data, either all of your data or some of your data, maybe depending on what you do, right? Also great, right? It's fully generated. Everything again is statically served off of your S3, but your build needs to assemble all of the data, makes it, makes that happen. I assume there are some hooks in those kind of systems that go and trigger the build on change. I don't know if they do incremental builds or not. I assume not. I'm sorry? It's coming. It's coming? Oh, we have a contentful person in the room. Perfect. Yeah. So my point is like usually these systems manage your data but not your build necessarily, and it kind of depends on your build system to be able to do incremental build only of data that has changed, right? That's kind of today that's kind of an issue from what I hear, right? And as websites grow, statically generated websites grow, people starting to feel the limit of this approach because of this problem. There is also another approach, right? As we just talked about serverless, right? If your main dynamic system or user interaction system uses HTTP REST API, let's say what's the API gateway from Amazon, right? And that's how you manage data. Well, you don't need to worry about your main skeleton of the website or statics page generated. You just deploy only static thing, and the production thing, the dynamic data comes from API on the fly. There is a cost to that, obviously. The problem of getting that data comes back to, well, that can be slow. That's definitely not as narrowly distributed as your statically generated things. It can be fast, right? Like, but our slowest request was like 1.9 seconds, right? Still high, right? And again, when we use some data store, like there's no magic, right? Like things take time to generate, right? Or whatever it's, the word generate here is to create, right? If you make a request, it takes time to create output out of it, right? So this last approach works maybe for like secondary content, like maybe how many of you use comments plugins, like Facebook comments or things like that, or some other service plugins, like, you know, like discuss, yeah, like, okay, they were called widgets back in the day. You will include it, it's somebody else handles it for me, I'm okay, my main content is managed through static, right? But none of these approaches really work for very data-driven systems like e-commerce, right, where prices change a lot, inventory changes a lot, just user contributions change frequently, right? And sheer amount of volume kind of makes some of this system break, right? Length of build, monolithic builds, it's kind of problematic. So essentially what I want to talk about is dynamic generation, right? I think my goal is to convince you that you can go and expand these techniques that we all love to all types of data, right? With some additional changes to your architecture, right? So whenever you come to your boss in your big enterprise account, some of you raised your hand, right? And they say, oh, static generation is only for blogs, or whatever their excuse is to not use static generation. You can say, well, we can make the same technique to make user experience very fast for similar technology, but we need to re-architect some of our systems to do dynamic generation. So the word static doesn't happen there, and they're like, oh, our data is not static, we are like dynamic, how can we use this shitty technology, right? Like they don't have that argument anymore. So I propose the dynamic, and by the way, I just realized, but that the group is called the new dynamic, which is exactly what we are playing at here, right? So let's call them dynamic generators. Again, this is not a technology that exists today that, like serverless, you can just type in dynamically generate my data. It's a set of approaches to do that, right? So if you go back to our generate with invalidation workflow, right? And expand a little bit, because we have a lot of data, right? A lot of data sources coming at different times and from different sources and all of that. First thing we need is to solve a problem of incremental build, right? And not incremental deployment, which is somewhat easier because once you build them, you can compare two sets of files and only deploy those that has changed, but or use timestamp to deploy. But incremental build, how to not regenerate things that didn't change. If you have a rate of change for your data at 1,000 a second, 1,000 rebuilds of the whole site is kind of problematic, right? Even if you narrow it down a little, segmenting, it's kind of hard. So you need to build some kind of system, which I call dependency manager, like it's right between the build and the data store, right over there, that little box, right? That will figure out what is that we need to rebuild, right? Things that probably need to be added to our current static generators. We are all waiting for that to actually happen and to work well, right? What does it do? First of all, it goes and figures out what is that we need to regenerate, right? Which files do we need to put on a disk drive and run that rendering process for, right? Then configure proper rendering variables. So good example, I listed a few examples, but there are probably other dimensions to your data, right? So for example, authentication role, right? For public user version versus, your member, person who signed up for your service versus a public version, right? Or administrator versus regular user, things like that. Another one is segmentation. People, let's say, based on your marketing campaign, right? They came from this link. We want to show them this type of the service versus that type of service. Very big in like new business where it's like, well, we want to be data-driven, right? Generation workflow is not against data-driven systems, right? We can still generate data-driven experiences. We just need to vary our output based on that. And another aspect with globalization, multiple languages, which users can come from very different locales, prefer different languages. By the way, geo distribution is another one, right? But you can generate. You support 5 languages. Well, you need to generate 5 versions of the output, right? And then this thing triggers the build with those parameters, that incremental build. So your build happens only for this subset of files, subset of files, and then cache keys, corresponding cache keys are triggered on a CDN, right? And well, your CDN will know how to convert for the same URL under one language or under one user account to convert it into a particular file, right? That is the kind of outside of this. And then you need to figure out how the hell do you manage all of these changes, right? How do you listen to all the changes in all of your data sources, right? That come, let's say give a e-commerce example again. Your pricing changes on this particular way, right? But your inventory changes in this particular way. Maybe it's a ETL, some kind of data pool for every day or every hour. But for pricing, maybe it's kind of complicated. Well, we're not talking about personalized pricing. Yeah, controversial topic, but maybe your images sync from another content management system, right? Data system and stuff like that, right? How do we do that? The only good way to really unify that, because we now need to know about all of the data changes. We cannot just say, oh, we'll just do this little one, right? Unless we go with the real-time API approach for things that we cannot dynamically generate. We need to handle all of the data sources, right? For that, the best approach is to create some kind of unified pipeline, and some of you, if you worked with event streaming subsystems, right, you probably would kind of find it familiar, right? Kinesis, right, that's the system at Amazon, but there are many enterprises look into this already, right? So when your data source changes, well, your business logic creates a new event, go save it to the database, and also send it to our dependency management system, right? So it can get regenerated and deployed. This is like a classic example of streaming setup, right? Pretty good way of doing that, right? A real world is a little more complicated because I wish we just built streamed system today, right? Usually they are introduced incrementally, one by one. So in reality, you probably will write some data into your databases the way that you do, like without any streaming. But also you can go and mimic that or mirror that update into your stream system. Most of the people probably do that in a similar fashion. In any way, in reality, our dependency management tool doesn't really need to know all the data that has changed. It just needs to know this particular entry in our system has changed, right? That's the minimum you need to know. And then it can go and actually use your regular web server like you do today, like the one that you didn't convert to generator yet, as a rendering engine, which will make that database request once it knows what is that we need to update, right? So this is probably the most realistic scenario for you to start implementing this, adding this to your system as you go, right? Primarily because your data people probably don't move as fast as we front-end folks do, right? So in reality, I don't really want to architect this right side for you, right? You need to figure out how to instrument your data systems to know when data is created, when it's deleted, when it's updated. What are those entities that you have? And that is a thing that you need to do, right? There is no way around it, because without knowing what needs to be, what your data is, you would not know what needs to be updated, right? Another interesting solution that I think might be a good abstraction layer is GraphQL, right? If you're not familiar with GraphQL, it's a new way of querying things, right? Very efficient, amazing. There was a session here before, right, on GraphQL. So GraphQL, in addition to managing all of those queries to your backends of different kind, it also has this concept of subscriptions, right? And subscriptions are basically like, okay, when data updated, go and notify the client that data has updated. So we could use, instead of some of that complexity with event system, maybe we can use a GraphQL front and with subscriptions. We don't do queries, we do subscriptions. For everything we want, we do subscriptions. The moment something changes, go and regenerate it, right? Can be an approach. I didn't work with this approach before, and I kind of, I don't know GraphQL personally, so don't have experience. But for this previous system, we actually did a prototype like that, right? And it worked very well. In fact, we used serverless. We used serverless to trigger a request to the web server to every time that the stream from Kinesis triggered another serverless. And I mean, it was a couple queues and a couple simple serverless functions to orchestrate this within Amazon environment, right? We didn't roll it out because it requires kind of to cover quite a lot of probably majority of your data sources before you can roll it out. So that's kind of a downside, but it is very achievable, very scalable. And by the way, effect was magnificent, right? You could see it with your naked eye. Forget about the tool measurement, right? You could see the effect with the naked eye, right? So figure out whatever you like your GraphQL more and stuff like that. This conversation is kind of that you need to have with your data teams, right? It's not a simple thing, but you can figure it out. I'm not worried. So, what is our to-do list to make that happen? First of all, figure out what are the real staleness and freshness requirements for your data. But because the first pushback I get is like, our data is dynamic, we cannot statically save it. And first thing I tell them, it's bullshit, right? Because your data doesn't update real time. Well, unless you maybe Wall Street trading system, by the way, also bullshit. They have like 15-second cycles and all of that, right? It's never real time. There's always freshness requirement. And when it's a inventory for your store or RSVPs to an event, right? We know when it updates, right? Like, it's very clear. It's just that it was never written down, so we rely on every time requesting it, right? So it's a huge bad excuse by data teams. Be ready. Make sure you know how your data updates. And kind of understand how it's done now in your system, right? Because one thing is a business requirement, as a business, like our users have to see data that is no longer than 1 day old, right? Another thing is how do you actually import it, right? Because business folks can think what they think, but ETL people will tell you how frequently it's imported, right? So be ready with that, and that will help you address this problem, because in the end, whatever you implement cache within validation or generation, you will need to know that. There is no other way, because otherwise you will be just very conservative on your TTL, and it will be like, okay, maybe if we cache it for an hour, it will be okay. And I've seen this approach fail a lot of systems, right? It's a good quick approach, right? When you're like, okay, let me guess how stale it is. How many complaints will I get from my business folks when it's stale, right? And things like that. But you do need to know this life cycle of your data before you approach any of this. I'm serious about it. It's like this is probably the hardest fight you will have in your organization, right? And then the product conversation. Map all of your inputs to your outputs. Which data used where, right? Remember those surrogate keys? It's not a simple exercise to know like when I update this field, which pages get to be updated, right? It's like not a straightforward thing in your complicated databases, right? When in static generation, it's kind of straightforward. It's based on the file you edited, but in databases, it's kind of a hard problem to achieve. Where in the code is used, like how it affects. It's like not a straightforward thing, but it could be done, right? Again, surrogate keys. Fastly uses that on the edge, but the same approach could be used to generate that mapping on the server, right? I have some ideas. If you want to talk, let me know. Then figure out your segments, right? What is personalized, what is not. If something is extremely personalized, maybe you move it to the front-end rendering and front-end requests, right? But if something is segmented, make sure you understand how many segments you have. Like I had this conversation before. Oh, we use geo, right? Geo-targeting. It means we cannot really know what the output would be. I'm like, really? You have 3 offers based on that geo? You have 3 outputs, right? Stop bullshitting me about like infinite amount of zip codes in the world, right? Or whatever coordinates on the globe. Like not really. It's about what content you need to output. Same goes about languages and roles and things like that. It can be a large fanning of data, right? You might be generating 20 outputs of one input entry and maybe 100 outputs out of input entry. But it is finite. If it's infinite, okay, then you go and do real time. Particular example here is actually search, right? Search engines have a lot of logic in it. You might want to use things like, not Sphinx, sorry, the other way around. Sphinx sucks. And I forgot the name of technology, but basically, very popular Spark, no? No, Algolia is a service, right? No, I'm talking about the, anyway, I'll try to find it if anyone is interested, but basically the idea is that you don't generate HTML output. The system keeps all it indexes like any search engine would do, but it will keep indexes in memory, right? So and it will reshuffle the output based on that. So it is data-driven, but it's much closer to static generation than people think, right? It does calculation on indexing stage, not in real-time request. No, Google doesn't go and search for your document in the world, right? It does indexing and keeps the results, right? So search is kind of one of those things where personalization is so narrow that you might not be able to do it. But hopefully you're not building a search engine, so search is not your primary function, right? Or at least it can be a very important function, but it's not the only function. More importantly, search engines don't care, by the way, right? About your search engine, right? They don't need to index the results of your search engine, right? Your users can be, your interface for search can be created in a way that is useful before search result comes back, and you know, it can be well optimized. And then I think you're done. Then you build your dynamic generation, build this event or whatever like trigger system that triggers incremental builds, and make your users happy because they will experience speed, buy more ads, no, click more ads, what is it? Buy more products, whatever drives you, right? Do more good, whatever that business metric is. So let's do that. And whoever does it first can make a presentation at this meetup, and we'll do a joint session with Web Performance Meetup too, right? Right? Yes. So perfect. So thank you. Do we have time for any questions? Couple minutes, couple questions. Anyone?
So what are the most popular, I guess, frameworks or libraries to organize this whole workflow? Are there any?
Well, this is the first time the word dynamic generation was used in the public. I'm kidding, not really. I think streaming setup is probably your common, like Kinesis, or there are Kafkas of the world. I'm actually not a streaming professional. I don't know enough of that. So for streaming, for that event process, in fact, they have a even concept called CQRS, which is basically static generation, kind of generate the output, basically write data for storage separately from your read data, basically generate the output. And you just need to extend it from generating the JSON or database entry to generating HTML, because in the end it's the same, right? What else in there? Well, maybe this GraphQL approach with subscriptions can work. Otherwise it's the same technologies, and there's nothing magical, right? Serverless, right? Like technologies are there, right? The question is, how do you trigger that in? I think one core concept of distributed systems and systems that can act on any type of data in any kind of way is small granularity, right? The moment you create small granular things, like with serverless, for example, and it ends up processed in the output, I think that's the key here. So not those long-running lambdas, right? But those incremental lambdas, like in our system, one was listening for the data change, generated the key for input. That one was picked up by another lambda, determined the fanning out, that dependency management, right? Which ones need to be updated, saved that into another queue, and that generator from the queue went and just hit the website for those URLs, saved them to the files, and that's it, right? So the moment, I think this approach is probably a good approach to follow. Thank you.
Thanks. Do you know if there are any, like this looks like the main use case that you've seen this used for in your own experience is like you have a dynamic site, you're using it to basically pre-generate a bunch of cached, and whatever pages or
pre-generated, not cached.
Yeah, so it's pre-generating by essentially like hitting an origin when this event happens, right?
Hitting an origin is an easy implementation. It doesn't have to be that way at all.
So
it
I guess
can be
my question
similar
is,
to static generators.
Do you know of any static generators, or have you seen, this approach start, like for example, incremental builds on static generators? Like what's doing that well? What are some tools that are starting to solve that problem?
None that I know of. In 2 words, right? Nothing follows this for universal data source. There are some optimizations, right? Every static generator today can probably optimize determining the outputs based on the input, right? And only build those, right? Using the very same flow for events, right? Like Git update, they can determine which ones I need to regenerate, which ones I don't, right? It can be done for this small ecosystem, but nothing uses this universal, like I don't care what I regenerate, right? Where data came from. And that is something what I'm proposing to build. Let's build it. Nothing magical, just need to do it. And this way we will be able to statically or dynamically generate every single website out there. Every single one. It doesn't matter if it's a data from your own business that comes at weird places, or if it's user-generated data. You can generate any data, right? They enter a comment, go the flow, post it. Some services actually do that already as a third-party services, right? But it can be anything. Rankings, content submissions, anything, right? That's the whole goal. Speed up the world. Okay, seems obvious. Let's do it. Thank you.
Thank you, Sergey. I will mention that Gatsby's working on that specific problem, though it's what Sergey proposes that we do this for everything. Gatsby's doing it just for static sites. So they plan on releasing something this year. So we'll see how that goes. Thank you very much, Sergey. Really appreciate it. That was a fascinating talk. Thank you, Jared from Serverless. That was also fascinating. Thank you, everybody, for coming out and being part of JAMstack. Please come to thenewdynamic.org, join our community, read the articles, and chat with us. Awesome. Bud, do you have anything to say?